We can also look at this formula for the option price. This was the value of the replicating portfolio at time H. Namely, we have risk-free interest on our T-bill of B, and the stock price has changed from S0 to SH. Now, this can be thought of as a line. The delta can now be thought of as a slope of a line, and let's see how that works. So in this graph, you have the familiar payoff function of a European call at expiry. And in our binomial option pricing model, we're assuming that the stock per share is either at US or DS. Notice that we ignore dividends for the exercise of the option. When the option is exercised, it'll be exercised at US or DS. Even if the stock pays dividends, it's only in the replicating portfolio where dividends influence the value of that position. The exercise value of the stock will always be exercised for one share. And so here we see US and DS, the two values of the stock. And delta is, in fact, by the formula we have, is the slope between CU minus and this run. So we can think of delta as being basically CU minus CD over U minus D. And we have a dividend adjustment in that, but this captures the majority of what is going on. We can see that the true delta of the portfolio is the slope of this line adjusted with a dividend factor. The reason this is important is this line gives you some intuition as to what happens if US and DS move. Namely, that for a call option, imagine what happens to delta as DS approaches K. You can see that the slope of that line approaches 1. And we'll see this later, that call options, as they move into the money, and if DS moved toward K, we would have an option that was always in the money. As a call moves into the money, its delta approaches 1. What happens if US approaches K? DS stays where it is. Well, the delta goes to 0. And again, we're going to see this in general terms, that the delta of an out of the money option approaches 0. And you can see that very graphically by the slope of that line. Again, the true delta is the slope of this line times that discount factor with the dividends. But the point is still the same, namely that as calls go into the money, the slope gets close to 1. As they go out of the money, the slope gets close to 0.